Welcome everyone. Today we are diving into foundational topic in the C programming language, strings. Let's begin by understanding what is string actually is in C. Unlike language like Python or Java, C does not have a built-in string type. Instead, string in C are implemented as arrays of characters. That's right, a simple one-dimensional array, but with a twist. Every C string ends with a special character called the null character, written as /0. So, what does means in practice? If you want to store the word hello in C, you are actually storing six characters HELLO and /0. The /0 tells the C where the string ends. Without it, she will keep reading memory behind the intent string, leading to the bugs or crashes. This is a crucial concept. C is a low level language, it gives you control over memory, but that also means we are responsible for managing it properly. Now, why should we care about strings? Because strings are everywhere: user inputs, error messages, configuration files, names, address, and so on. If you play, plan on working with text in any form, strings are essentially. Throughout this session, we will go behind just theory. We will look at examples, functions, syntaxes, syntax, functions, usage, and some hands-on coding to help you understand how string really works in C. So, with that introduction in mind, let's move on the definition of strings and explore how they are declared and initialized in actually code. Definition of strings in C. In C, a string is formally defined as a one-dimensional array of characters that ends with a null terminal, that is the /0 character we talked about the earlierly. Let's dig into that. A one-dimensional array is just a sequence of elements arranged in a line, and why when those elements are of type char, we have a character. We have a character array. For example, char string equal to hello is a wild string in C. Now here's something interesting. Even though the word hello contains 5 letters, the array actually contains 6 letters because C automatically adds the /0 at the end when you use double quotient. You might ask, why use arrays for strings at all? Why not have a built-in strings type like in other language? When C was designed to be as close to hardware, giving you maximum control, including how strings are stored and manipulated. This definition leads to a lot of power, but also a lot of responsibilities. You need to be carefully with memory allocation, size of arrays, and making sure that the null terminator is present. Without this understanding, you might run into the issues like buffer overflows, unintended character being printed, or segmentation floats. Now that is we have defined what a string is in AC. Let's explore how to declare and initialize string in your code, a foundational skill every C programmer must master. Declaration and initialization. Declaring and initialization strings in a C is just straightforward. Let's look at this syntax. Char string 10 equal to hello. Here we are declaring a character array named string with a size of 10 and initializing it within the string hello. Now hello is a 5 characters, and with the /0 it becomes a 6. So we will still have 4 unused characters in the array. That's important, especially when you want to manipulate or append it to the string later. Here another way to do it. Char name 20 char message equals to welcome, char greet equals to hi slash 0. In the first line, name 20 re- reserves space for 20 characters but does not initialize them. You typically used input functions to fill it later. The second line, message is initialized directly and C figures out the size based on the content. 8 characters including the null terminator. In third, we manually provide a character including the slash 0. This is a very explicit and clear way to define a string, useful when dealing with a character level operations. A key takeaway is this: always ensure your strings are properly null terminated. Otherwise, C functions like printf or string length will not know where the string ends, leading to unpredictable results. Now that we know how to declare and initialize a string, the next logical step is to learn how to input strings from user and output them back. Let's take a look. String input method in C. Welcome back. Now that we know how to declare and initialize a string, let's learn how to input string from user in C. C provides multiple ways to read strings from input. However, not all of them are equally safe or reliable. Let's walk through the most commonly used ones. First, using scanf percentage %s string. This is the simplest method. You use the percentage %s format specifier to read a word. Character string 20 scanf percentage %s string. This works, but here catches scanf stop reading at the first white spaces. That means if you enter hello world, only hello gets stored word is ignored. Another corner buffer overflow. If the user enters more characters than the array can hold, it causes memory corruptions. Always ensure your area is large enough for expected input. Using getString deprecated. At one point, get was popular because it reads an entire line including space, but it's now considered dangerous and has been officially deprecated in the C11 standard. Why? Because get does not allow you to set the maximum size. So if a user type is in a more characters than your array can handle, your program could crashes or behave unpredictably. Cat string 20 get string. In modern C, avoid gets completely. Most compilers will even show a warning. Using fget string size standing recommended. This is the recommended and safest method to input the string. It allows you to specify the maximum size of the input buffer, preventing overflow. Character string 50 fget string size of string strin. This reads an entire line including space and automatically appends a null terminal. However, one small downside is that in writing the new line character at the end, you may need to remove it manually using a loop or by checking if the last character is Asian. Despite that, fgets is your best friend when it is comes to inputting strings safely. To summarize, you can input strings is the three means: scanf, get gets, fgets. Scanf means good for single words but unsafe for long inputs. Get means deprecated and unsafe, avoiding using it. Fget means safe, flexible, and handles space. The best choice for modern C programs. String output methods in C. Now that we have learned how to take input from users, it's time to explore how to display those strings because no program is complete without some kinds of outputs right. C provides a few standard and simple methods to output strings. Out C provides a few standard and simple methods to output string. Let's break them down and discuss their usage, pros, and subtle using printf. First one is using printf with the percentage here. Let's start with the most widely used method. Char string equals to hello world. Printf percentage s and strs. Here, percentage s is a format specifier for strings. When you use percentage s, printf starts printing from the memory locations of the first character and contains until it encounters the null characters person slash zero. This is a powerful and flexible method. We can mix a string with other data types like integer and floats. Char name equal to Aline's age 25. Printf name percentage age percentage name age. Output name Aline's age 25. It's a perfect for format output, especially when you are displaying structured and labeled data. Second one, using puts. This second method is a puts function. Char message equal to welcome to C programming. Puts message. This will output the entire entry string followed by a new line character automatically. In contrast to printf, puts is simpler. It does not require a format specifier and it always ends with a new line. So, if you need to display a string and move to the next line right after puts, it is a quick and clean option. However, it is a flexible. We cannot combine it with other variable or format the output. It is purely for printing a full string as in. Depending on the context, we can choose one or another. For quick prints, puts is a great for anything or dynamic or data rich. Printf is a better option. Features features printf and puts flexibility, high flexibility, limited. New line behavior you decide automatically add. Formatting supports complex formatting, no formatting support. A note on output safety. When printing string, make sure there are null terminated if the slash zero is missing. Printf percentage s string will keep printing memory past your intended string. This can crash your program and printing garbage values. Also, never forget to ensure that your array size is large enough to hold the full string, especially if you are combining input and output operations. String function overview. Now that we have covered input and output, let's explore the powerhouse of string manipulation in C. The built-in string functions. C provides a standard library called string.h, which contain a variety of functions that make working with strings much easier. These functions can help us with everything from measuring the length of a string to copying the string to comparing them. It's an overview of the most commonly used string functions. First, string length. Finding the length of a string. The first function we'll look at it is a string length, which returns the number of characters in a string, hash including string.h character string equal to hello, int length equal to string length string, printf length of the string, percentage of the length, output is length of the string 5. This is the essential function. Whenever we are working with the string, we will often need to know their length. Remember, string length does not count the slash 0 characters, just the visible characters. String copy, copying one string to another. Next up, we have string copy. We have string copy, which is used to copy one string to another. Hash includes string.h character string copy equal to hello, string dst10, string copy test, string printf destination string. Percentage of is destination. Output destination string is hello. Here, string copy copies the content of the string copy into destination. Be carefully with the string copy through if the destination array is too small. It will cause a before overflow leading to undefined behaviors. Always ensure the destination array is large enough. So third one, string cat, concatenating string. Now let's talk about concatenation with string concat. Include string.h, cat string 120 equals to hello, cat string 2 equals to a string cat string 1 string 2, printf concatenate string percentage of s and string. Concatenate string is hello world. String concat append the second string to the end of the first string 1. Again, B. Catenation ensure that the first string has enough space to accommodate the result. Otherwise, we will run into the buffer overflow issues. String compare. Comparing the string. Another commonly used function is string compare, which compares two strings. Include string.h. Int result equals to string comparing apple, banana, printf comparison result. Percentage of the result output comparison result is 1. String comparing compares two strings lexicographically. If the string are equal, it returns 0. If the first string is lexicographically smaller, it returns a negative value. And if it is a large and positive value, in this case, apply it is smaller than banana, so the result is negative. String reversing a string. If you want to reverse a string, we can use string reverse. Note that this is not a part of the C standard library, but it is available in many compilers like a turbo C. Hash include string.h. Cat string equals to hello. String reverse string. Printf is reverse string percentage of s string. Output reverse string. While the function is the convenience, remember that it is not available in every C environment. So be carefully when using it for a cross-platform code. String lowercase and string uppercase functions. Now let's diving into two interesting string functions, string lowercase and string uppercase. Both of these functions are used to convert string to lowercase or uppercase, respectively. These are non-standard functions, meaning they may not be available in every C environment, but they are commonly in many compilers. Let's go through each one. String lower string String lowercase. Converting the string lowercase. String lowercase converts all strings in a string to lowercase. Include sdio.h. Include string.h. Character string equal to hello world. String lowercase string. Printf lowercase strings percentage of s string. Output lowercase string hello world. As you can see, string lowercase change the case of the all the letters to lowercase, leaving any non-alphabetical character unchanged. String uppercase convert to uppercase. On the flip side, a string uppercase converts all characters in a string to uppercase. Hash include sdio.h, include string.h, character string equal to hello world, string uppercase, string, printf uppercase strings percentage of a string output, uppercase string hello world. Like string lowercase, string uppercase affects only the alphabetical characters, leaving the non-alphabetical ones intact. While string lowercase string uppercase are useful for quickly changing the case of a string. Remember that they are non-standard and not universal available. Use them with the catenation and always checks for your compiler supports them for more portable solutions. You could manually convert characters using loops and conditions. Next, we will explore more advanced topics like multi-dimensional string, passing a string to functions, and palindrome checking. Character arrays versus strings in C. Now let's talk about an important distinction. Character arrays versus strings. At first glance, and character array might look like a string, but there are subtle differences between the two. Character array, not a string. In C, an array of characters can be written like this. Character array equal to hi. This is not a string because it lacks the null terminator #0 that marks the end of a string. It's just a sequence of a character and C will not recognize it as a string. Without null terminator, functions like print a percentage of S array or string length won't work correctly because C has no way of knowing every the array ends. Second, string null terminated character array. A string, on the other hand, is a null terminated character array. Here an example. Character string equal to hi/0. This is a valid string because it ends with a null terminator #0. C will recognize it as a string and functions like string length and printf percentage of s and string will work as expected. Third one, important takeaway. The key differences is the null terminator. For C to recognize something as a string, it must be properly null terminated. When working with a string, always ensure that we are dealing with arrays that ends with a 0. When manipulating or copying them, make sure you don't accidentally override the null terminator. Multidimensional strings in C. Let's now talk about multidimensional string. This might sound complex, but it is actually a very powerful tool. A multidimensional array in C can store multiple strings. Think of it like a table where each row is a string and each string is an array of characters. For example, here how you could store a list of names. Pair names 310 Ram, Sham, Mohan. This is a two-dimensional array. The first dimensional 3 represents the number of strings and the second dimensional 10 represents the maximum length of each string. You can access each string by referring to the indices just like a regular 2D array. Printf percentage of s names 0. We can use multidimensional arrays when dealing with a collection of strings like a list of names, cities, or any set of textually data. They are extremely useful in scenarios where you need to manage multiple strings efficiently. Reading string with spaces. When it comes to reading string from users, you face a common issue spaces. By default, functions like scanf percentage of a string stop reading into at the first space, which is not ideal if you want to allow user to input string with spaces, such as full names or sentences. Using fgets are strings using space. The solution is to use fgets, which reads an entire line of text, including space. Cat string 50 fgets string size of string sdn. With fgets, we can read a full line of text, space included. The function takes three arguments: the buffer to store the input, the maximum size of the buffer, and the input stream, usually SDIN, for standard input. Why not scanf for spaces? For demonstrate, let's try using scanf to read a name with spaces. Char name 50. Scanf percentage of S name. If the user entries John Dean, only John will be captured, but with fget space will be read properly and the entry name will be stored. Passing string to functions. One of the most important concepts in C program is passing string to functions. We will often need to pass string as a argument to functions. For example, to display or process them. Passing string by reference. In C, strings are passed to functions as pointers to their first characters. This means that when you pass a string to a function, we are passing the memory addresses of the string. For example, white display as string, printf string percentage of a string. Here character string is essentially a pointer to the first character of a string. You can call these functions like so. Char name equal to lc display name. This will include the string name. Returning string from functions. Next, let's discuss returning functions from functions. You might think it's simple, but it can be tricky if you don't handle memory correctly. Returning strings safely. In C, we cannot directly return a local string from a function because local variables are stored on the stack, which is clearly when the function exists. One approach is to use stack memory. Character get greeting. Stack char string equal to hello world. Return string. Here string is a static variable, meaning it persistent behind the function's scope and remains valid even after the function exists. Palindrome checks. A palindrome is a string that reads the same forward and backward, such as a madam or a race car. Let's look at how we can check if a string is a palindrome in C. Palindrome function. It is a simple function to check for a palindrome. This function compares characters from the beginning and end of the string working towards the center. If any pair does not match, it returns 0 to indicate it is not a palindrome. Length without string length. In many programming tasks, we might find yourself needing to manually compute the length of the string, especially in cases when we are avoiding standard library functions or building low-level algorithm. Here we have to do it. Int find length characters. Int length equal to 0 while length equal to slash 0 length plus return length. This function counts characters in the string until it hits the slash 0 returning the length. Reverse string. Now let's explore how to reverse a string. Reversing string is a common problem in coding exercise and it is a great practice for understanding string manipulation. Reversing with a loop. We can reverse a string by swapping character from the front and the back. This loop swap the character at the start and end, moving towards the center until the string is reversed. Concatenate without string cat. Lastly, let's look at how to concatenate two strings without using the string cat function. It is a useful exercise to understand the inner working of a string manipulation. Manually concatenation, you can append characters from one string to another manually using a loop. This function finds the end of the first string and appends characters from the second string. You manually manage the null terminals at the end. Summary. To wrap up things up, we have covered a lot of ground today. String in C are array of characters with a null terminal as 0. We learn how to declare, initialize, and input string. We discussed various output methods using the printf and puts. We explored input string functions such as a string length, string copy, strcat, string compare, and string reverse. We looked at manipulating string case with the string lowercase and string uppercase. We distinguished between character arrays and strings in C. We learned how to pass string to functions, return string from functions, and check for palindrome. String manipulation is a crucial skill in SC programming, and understanding the nuances of handling strings efficiently and safely will take your coding to the next level.